Good morning. This is Michael Dong speaking on episode number 20, UHPLC, Potential Issues and How to Get Started. Here is our agenda. We talk about potential issue and how to get started, which is the first one is how to mitigate some of these potential issues. And the second one is how to get started and transition from HPLC to UHPLC, end fittings, and others. This video is based on a white paper published in 2017 called HPLC UHPLC3 Potential Issues. Here are 6 listed potential issues. Some of these are real, some of these are perceived, others are historical. Starting from number 1, safety issue, viscous heating, system and operation nuances, injection precision for earlier system. We focus on the last 2, UV detection sensitivity, primarily from pump blending and trade-off mixing volumes, and also method translation or conversion issues. Safety issue has been addressed by Professor Milton Lee. According to Professor Lee, due to the low volume of the flow rate and small compressibility of liquid, UHPLC poses little inherent danger because there's no latent potential energy being released, unless one is not following safety procedures such as disconnecting the inlet pressure under very high pressure without safety glasses, etc. A viscous friction heating, there are 2 types of thermal gradient caused by high pressure and reasonably high flow rate. One is the radial direction across the radius. The other one's along the column, length of the column. Radial thermal gradients results in efficiency loss due to extra column band broadening, shown here in this diagram here, where in the middle of the flow is hotter and they're less viscous, leading to a parabolic flow profile. But after much research, it's really not an issue with most column oven because most of them have pretty poor heat dissipation from the stainless steel column wall. So unless the column is thermostatic in a water bath under isothermal condition, it's not a practical problem. The second one is longitudinal thermal gradient, which are undissipated frictional heat that increases the column temperature at the outlet by up to 5 to 20 degrees. If one touched the end of the column under high pressure and reasonably high flow rate, one can see that the end of the column, UHPLC column, is much hotter than the set temperature and the inlet temperature. This could be a problem for fast gradient analysis, requiring several injections to get thermal equilibration. So the effect of viscous heating is really not considered to be a serious practical issue for most column oven. And the longitudinal thermal gradient could be a problem if in a very complex chromatogram there are some selectivity changes with different temperature. But in general, it does not cause any co-illusion in most cases. 2 references being shown here, 1 and 2. Number 3 is system operating nuances, such as system cost, operating training, instrumental dispersion, extra column band broadening, dwell volume issues, and also flow rate range and backward compatibility. We would focus on the last 2. A case study, peak area precision. This is using Agilent 1290 with a split loop autosampler, which is renowned for highly precise volume precision, even at very low injection volume. Shown here is the actual data, seeing that even at down to 0.2 microliter, the relative standard deviation of the precision is even better than 0.5%, which is outstanding. A UV detection sensitivity could indeed be a problem for the earlier systems, shown here in the data collected in 2006 data, published in 2007 paper in LCGC magazine. This is an application of injection of an excedrin drug product, okay, showing 3 peaks of caffeine, acetaminophen, and aspirin, which is acetylsalicylic acid, with a degradation product, salicylic acid. We used a pump to blend the mobile phase, which is 11% acetonitrile and 0.1% acetic acid in water. And we observed a UV baseline perturbation, which is pretty significant. As it turned out that these perturbation does not come from the detector and came from the inadequacy of the mixing, also somewhat related to the pump design. So to get rid of that perturbation, one have to use a larger mixer. Once you use a larger mixer, such as a peptide mapping mixer, which is 500 microliter, the noise essentially go away. In terms of method conversion from UHPLC to UHPLC, there's 3 scenarios. First one is to use the same HPLC method on UHPLC equipment. And it's the simplest conversion, and there's really nothing to be done except to expect a slight shift or retention time due to lower dwell volume from the UHPLC system. Second scenario is the back transferring. If you develop a method on UHPLC and if you transfer a method to a different laboratory without UHPLC equipment, then you have to transfer the UHPLC condition into HPLC condition, using the same bond phase, and we talk about that in a little bit more detail. These are needed to support global manufacturing. The third condition is to convert all the existing HPLC method into UHPLC method for better productivity. However, when you do that, even though you can reduce analysis speed by 2 to 3-fold, for validated HPLC method in pharmaceutical regulated testing, you will require a partial method validation and also method equivalency verification. So in most cases, this could be very difficult for commercial product or during drug development project. Here is a little bit detail on how to back convert a UHPLC method to HPLC. Condition number 1, you must select a column with the same exact bond phase, the same chemistry, and also similar plate count, right? For instance, if you convert acuity 1.7 micron column method, 5 centimeter long, you use the same bond phase called X-bridge, twice the particle size, twice the column length, so that one would have the same column efficiency. And also notice that the inner diameter is also much larger, 3 versus 2.1. You must scale the flow rate to the column size or to R square, the radius square, or ID square. And you scale the gradient time in the gradient method to the column length, and scale the injection volume to the column void volume. These are discussed in this white paper. Also, one can find actual conversion program from thermal Fisher Scientific, Waters, and Agilent website, or from this website called HTTP HPLCtransfer.com from University of Geneva by David Guillaume. This is an Excel spreadsheet, and it's very useful. In this case study, we observed the same legacy HPLC method based on Agilent 1200 and use it on 1290 binary pump. Due to the smaller dwell volume, one can expect a slight peak shift in this gradient method, right? So you have a peak shift or anywhere from 0.8 to 1.4 minute, depending on the retention time of the peaks. Also observe that the peak height of the early eluting peak, eluting almost under isocratic condition, are much higher in the UHPLC system because of the smaller system dispersion, right? The peaks are sharper. However, the peak area does not change. How about for USP method? What type of method adjustment are allowed? And here's some guidance from a paper from John Dolan and Dwight Stahl in 2017, showing you the acceptable allowed range as published in USP. The essence is that, for under isocratic condition, one have a large leeway, but under gradient method, there's very little leeway that you can change without, without doing, kind of not doing a method validation by just calling it a method adjustment. This slide highlight how to transition from HPLC to UHPLC. What are some of the consideration, which vendors should you use? First to consider is the application, whether you really want to do primarily method development or routine testing. Is it for research or QC, or is it for LC mass spec? Second major consideration is the control software CDS. It is much more advantageous to order the same UHPLC from your CDS vendor. Also, often the mass spec that you're going to run on it, which might have a different control software, might actually trump the other consideration. A third one is compatibility to existing method. Different system, some are more compatible to legacy HPLC method. Also, you might have a choice for intermediate system or dual purpose dual path system. Finally, one might have an option to choose different options such as a mixer, particularly for binary pumps. And most likely you would choose a larger mixer for regulated testing. Here's a listing of some of the manufacturer, the data system, the kind of mass spec that is being offered, maximum flow, and maximum pressure. Here's a listing of useful UHPLC fitting. The best choice is mostly the one which is finger tight compatible, shown here the optimized technology and the IDEX Optures VHP 3200, which is finger tight. This one is wrench tight. Also very acceptable is the Dynex Viper, which does not have a ferrule but have an O-ring with a flange tubing. For the column outlet of UHPLC, you do not need a more expensive UHPLC fitting. The regular IDEX Upchurch one piece, which is very inexpensive and works really well for the outlet, is totally adequate. This slide summarizes the performance trade-off in UHPLC design. Consideration instrumental bandwidth or system dispersion. System precision was highly dependent on autosampler design. Most of the modern autosampler are made from a split looped, so precision really is not an issue. Detector UV detection sensitivity, particularly for binary palm, would be contingent on the mixing volume. So probably a good idea to choose a slightly larger mixer for high sensitivity stability indicating method development or assays to increase the blending efficacy. Other consideration are the piston volume, which you have very little control, and whether the pump actually have a variable stroke capability. If one like to run legacy older HPLC method, then backward compatibility could be an issue, such as the oven size, the sample loop size that one have to be aware of. Occasionally, maybe flow range, and so on. So there are many design trade-off balance between system performance characteristic from the manufacturer's point of view, reliability, cost, etc. Here's my summary and conclusion. UHPLC is a newer HPLC platform offering high performance in speed resolution and even in UV sensitivity if you use an extended path length UV flow cells. It's useful in method development. It can cut method development time in 3 to 5 folds. Highly suitable for QC or regulatory testing. To consideration is system compatibility to legacy HPLC method using larger column, longer column, and also higher flow rate, and also larger injection size. So some of the UHPLC system might not be that compatible. You might have to buy additional equipment. There are many design trade-offs for manufacturing operating nuances for user, such as the list below, instrumental bandwidth, dwell volume, precision consideration, blending efficacy, and method portability. To get started in UHPLC, one have to select the appropriate instrumental vendor, select the right model, the right configuration. There are always trade-off between different options, binary versus quad pump, mixing volume, etc. There's always a little bit trade-off. Learn how to translate or convert method between HPLC and UHPLC. So all major manufacturers have UHPLC offering, and there are additional choices with intermediate pressure or dual path systems. Here are my UHPLC reference list. The two highlighted in red are the most important. On that note, we completed episode number 20, UHPLC potential issues and how to mitigate them and how to get started in UHPLC from an HPLC lab. Please subscribe for future videos, and we see you next time. Bye.